I think that it's in human nature to explore.
Understanding the moon better will help us to understand our neighbors in the solar system.
We're exploring the solar system here, not just the moon.
The moon is the natural next step in our exploration of our own universe.
The Lunar Reconnaissance Orbiter is, as its namesake says, a reconnaissance mission to the moon. Our job is to take a suite of very powerful scientific instruments and make an atlas of the entire moon, in some places in very great detail. Topography, mountain heights, mineralogy, temperatures, abundances of resources, including potentially the intriguing possibility that there's water at the moon. We put all this together into a data set by flying low over the moon for a year. This is the data that the people designing the systems, picking the sites, need to take us back to the moon.
Well, we learned much about the moon from the Apollo program, but now we want to return to the moon for a more intensive study. We want to be able to go back to the moon so that we can live there for long periods and work on the moon. So we need a mission that can help us find the best places to go and determine how to go back there safely.
We know that, Neil Armstrong and some of the others had a difficult time finding a safe landing site. They didn't see it till they got there, but now with our instruments we'll be able to tell people ahead of time, look, don't go there.
LRO will have a laser system that will give us a high-resolution topographic map of the moon. It also has high-resolution cameras that will identify objects that are only a foot or two in size so that we know where there are no large boulders that could be a risk to astronauts.
So our job is to literally complete the job of mapping the moon, do it at high resolutions, and enable the designers of the human systems the atlas they need to pick the safe places to go, the beneficial places to go, and where it's most fruitful to go.
In addition to the safe landing sites, LRO is looking for potential resources. And why are we doing that? Because it's really hard to carry all your supplies with you. I mean, you can do it, but you really spend a lot of not only fuel, but cargo space. So it'd be really nice to go to a place that already has the resources, whether it's water, ice to have water, or potential minerals that we could use as raw materials to make into things that we would need.
We think the most interesting parts of the moon may be the polar regions of the moon because there could be resources there. And so we're going to study intensively the polar regions with LRO.
From the Apollo era, we chose to go, for good reasons, because it was literally the easiest, to go to the equatorial regions and to stay a very short time. It was a very ambitious program, but when you look at where would you like to go and stay for a while on the moon, you begin to realize that probably the poles are the most interesting place.
Access to solar power continuously, that may be the first and most important reason over the near term. And then the possibility of resources being there. Those may take a much longer time before we're able to really exploit those. But the solar power is something we can exploit right away.
The second big resource on the moon may be water ice. There's evidence from earlier missions that in dark places at the poles, there may be water at the surface or below the surface in the form of ice crystals. If it is abundant, astronauts could use this for both human consumption and as a source of rocket fuel. LRO will measure for the first time this very energetic component of the space radiation environment in order to see whether it's going to be a problem for humans or not.
It was one thing to go for a handful of days in Apollo, and go when you knew that the sun was quiet, or you hoped the sun stayed quiet, and you took the risk, you calculated the risk of cancer and such, and you made a short mission. You're going to live there longer, you need to understand it well enough to go, here's what I need to do to protect myself.
One of the things that we're looking for in the LRO mission is how the high radiation environment affects our ability to explore. So if we bring cameras or communication devices, how will they be impacted by the cosmic radiation? We need to protect our equipment as well as ourselves.
When we look back on what we did in LRO and we look at what followed, I think we'll see a profound impact. We'll see us as really being the small first step where we have human beings permanently off this planet, beginning to move out into the solar system, starting with the moon. As that pans out, I think we'll be a small piece of a profound development that when history looks back, say this time we went back to the moon, this time we stayed, and we moved on from there.